So today's topic is how we find the line of intersection with two planes. So two planes, if they're not parallel, they will intersect. And the question is, how do we find the line of intersections? And now there's two ways to do it. The first way is you simply, wait, what? Okay. My pen is a little weird. Give me a sec. My pen is not responding. Okay, sorry about that. So there's two ways you can find the line of intersection with two planes. The first way is the simple old linear algebra method. LA, Los Angeles. What happens in Vegas should stay in Vegas. Nah, it's not even remotely related. The old linear algebra method. Okay. And the second way is a Calc 3 style. So, and it doesn't matter which method you use. Either way will give you the same answer. So let's try one. Let's find the equation of a plane that passes. No, sorry, not that one. Okay. Find the intersection, the line of intersection for these two. So let's try this one. Okay. The first plane is x plus y plus z is equal to 1. And the second one is x minus 2y plus 3z is equal to 1. And what we do in the linear algebra method, this is why it's like recommended you take linear algebra before taking Calc 3. It's not mandatory, but like it's because you're more flexible with it. So you have this 1, 1, 1, x, y, and z is equal to 1. 1, negative 2, 3, 1. And here I'm going to label this top here x, y, z. Okay. Now let's what you know is that these lines are not parallel, so they're definitely not going to have an inconsistent system. And if you learn in your linear algebra, I think it's by the rank nullity theorem, the dimension of your null space will be at least 1, and you're going to have at least one free variable, or maybe exactly 1. You're going to have exactly one free variable since it's the line of intersection. So this method is safe. What we do here is now we often let the rightmost variable be the free variable. At least that's what I do. So R1 minus R2 goes to R2. So nothing happens at the top. 1, 1, 1, 1. And down here it's 0, 3, negative 2, and 0. Is that right? Yep, that's right. Okay, what you do now is you focus on this term here. We want to make this equal to 0. So let's do 3R1 minus R2 goes to R1. And when you do that, it's 3, 0, 3, and 3 times 1 minus 0 is 3. So, and then the bottom stays the same. So 0, 3, negative 2, and 0. Now, this can be factored, divide by 3 for row 1. So this leads to 1, 0, 1, 1. 0, 3, negative 2, 0. 0. Okay. So our free variable is z, so it's x, y, z. So let's just say z is equal to t. Okay. X here, x plus z is 0, 1. So x is 1 minus c, or x is 1 minus t. And y is equal to 2 over 3t based on here. Yeah. This can be written in a vector form, which looks like your starting point 1, 0, 0 plus t, -1, 2 over 3, and 1. Let me see, is that, wait, hang on, why does my answer here look so different from, hold up, I might have made a mistake somewhere. It looks a little strange right now. 3R1 minus, no, this should have been a 5. Oh, I am so sorry about that. It's 3 times 1 plus 2, that's a 5. I am so sorry for that. I made a mistake. Okay, so 5, 1, 0, okay. 1, 0, so I think it's 5 over 3. Yeah, this is why I don't trust my mental arithmetic. Double check your work, guys. All right, so now we can, so 1 minus 5 over 3t. Oh yeah, okay. 1, 0, 0, negative 5 over 3. Sorry. But because I'm fancy and I like to have these, the direction vector as whole integers, I'm going to rewrite this as 1, 0, 0 plus t and multiply this by 3. So -5, 2, 3. There we go. The old-fashioned linear algebra style, guaranteed to have a line with dimension 1 where z is your free variable. So there you go. Now let's try another one. Okay, so this time it is 3x plus 6y minus 5z is -3. 3x plus 6y minus 5z is -3. And -2x plus 7y minus z is 24. 2x plus 7y minus z is 24. Okay. Now I'm going to use the second method this time, since I already used the first method. I'm going to use the second method to find the line of intersection between these two planes here. So basically, let's call this P1, plane 1, and let's call this plane 2. Plane 1 has a normal vector. The plane 1 normal vector is equal to 3, 6, and -5. So 3, 6, and -5. P2 has a normal vector of -2, 7, and -1. Okay, now this may be a little hard to visualize, but the direction vector of the line will actually be perpendicular to the normal vector of these two planes. And like, just try visualizing this. Like, let's say you have two planes, be anywhere in R3. And if they when they do intersect, it's like, it's a little hard to visualize, but the line here will be, this line is going to be parallel to the normal vectors of these planes. Yeah, take my word for it. It's true. So yeah, that's basically, so now we applying this knowledge, we use the cross product. To find the direction vector, dv, or direction vector, okay? So let's just apply that into use. I, j, k, 3, 6, -5. -2, 7, -1. Okay, so when you do that, that's I, 6, -5, 7, -1, minus j, 3, -5, 2, -1. Plus k, 3, 6, -2, 7. And that is equal to, let me think, -6 plus 35 is 29, 29i, 29. -3, plus, wait, hang on, -3. There should have been -2 here. Sorry about that. -3 minus 10 is -13, but it's minus 13, so that's plus 13. 33. I know it's 33. Okay. This is the direction vector for the line of intersection. This vector here, 29, 13, and 33. Now, all we need to do is find a starting position for this vector, and it could be anywhere you wish. Like the starting position, as long as you have the direction of the vector of the line, just choose anywhere to find the starting position. I always like to use the XY plane or where z is equal to 0. This is just my choice. You don't have to do this. Okay, so for z equals 0, let's find the point of intersection on the XY plane. So 3x plus 6y is -3, and -2x plus 7y is 24. I like to keep things in simplest form, so why did I write a 3 there? Okay, so x plus 2y is -1, and -2x plus 7y is 24. Okay, this is just a system of equations now. So 2x plus 4y. Actually, no, I could have just divided by 1.5 here. Silly me. -2x plus 7y. I can see why they require a PhD for you to teach, but I'm not willing to waste all those years. No offense to you, professors. You're awesome. 11y is 22. Y is equal to 2. Okay, and x, let me think. 2x plus 2y is -1. X plus 4 is -1. So x is equal to -5. Yeah, so x is -5, y is 2, z is 0. This is the starting point is on the xy plane. So the line of intersection of the plane is starting at -5 to 0 plus t, the parameter, 29, 13, 33. Obviously, you could have used the old linear algebra method and you would get the same answer here, but I just wanted to try a different method to show you it also works. Okay, so, and I encourage you for the other problem here, where with these two planes, you can try the Calc 3 style, where you'll get the same answer. All right, so that's all for today. I'm gonna give you guys a practice problem. So here, to see if you understand it, one practice problem will suffice. This is not that hard. Unless you want more, then just simply let me know in the comment section or shoot me an email. Although I haven't been looking at my email too often. Sorry about that. Okay, so here, had it right here. Let's see, is this a good one? Yeah, give me a second. I want to see. Sorry, I had my eyes like just zoomed in on one thing for a second. It almost felt like I had dyslexia. I know I don't, but like it almost felt that way. But I found the question. So here, the question is, find the line of intersection between these two planes. 2x plus y minus 2z is 3. And x minus 3y minus z is -2, using both methods. And when you do it correctly, you should get an answer of 110 plus t 101. So yeah, give this problem a try and let me know if you have any questions. That's all for today. I'd love to stay, but for now, I have to jump. I'll see you guys on the other side of the bridge. Catch you next time.